Alrighty, in this video, I want to go over the concept of a limit and show you guys how to find limits from both graphs and a table. Alright, so let's start off with the concept of a limit. So what's the definition of a limit? Well, the limit of f of x as x approaches a is denoted by this symbol here. And let me highlight it. So all of this is a symbol. And the way that you read this symbol is saying it's the limit, LIM is the limit, as x, and that arrow is pointing towards a, so as x approaches a, of some function f of x. So this limit has to equal a real number L, okay, more on that in a second, if the values of f of x are sufficiently close to L as x gets close to a. Alright, so I know that's a mouthful, so here is kind of a plain English definition. That is, a limit is the output, or the y value, however you want to specify it. The limit is the output that the function is trending towards. Okay, so what is the output value? What's the y value that you're approaching as your x gets close to some value a? So when we get to the actual problems, a will be an actual real number. Okay. All right, so there's some quick little additional things we have to go over before we can jump into some actual problems here. There's this thing called a theorem. It's just a rule that's been proven true over time. There's a limit that says if the limit as x approaches a, now you'll notice this superscript on a, this power on a, so to speak, there's a negative sign there. More on that in a second. So if this limit as x approaches a with this minus sign of f of x equals L, and the limit as x approaches a, but now it has a plus sign as a superscript, if that equals L, then the limit as x approaches a without a superscript of f of x also has to equal L for some real number L. Okay, so I know that seems very confusing at first look, but it actually makes a lot of sense once we look at it in more detail. So this first limit over here, the limit as x approaches a with the minus sign as a superscript, this is what we refer to as a left-hand limit. Okay? And what that means is that we are approaching that x value of a, we're approaching it from the left side of a. Meaning we want to get close to a, but we're looking at values that are slightly smaller than a. So if I could draw a picture here. So let's say we have a number line. Okay? And let's say we have a on that number line. What we're saying is that there are different ways that we can approach that value of a. What I'm saying is if we approach from the left, what we're saying is we're getting closer and closer to a, but we're looking at x values that are slightly smaller than a. That's what that means when you approach from the left. So if we approach a from the left and we get some output value, or y value of L, okay? And then the other part of this theorem says, what if the limit as x approaches a from the right of f of x equals L? We call this a right-hand limit. Okay? So what we're saying here is if we approach that x value of a from the left and we get some limit L, and we also approach that same a value from the right. So now we're talking about values that are slightly larger than that x value of a. And if we're also getting a, then what we're saying is this last limit here, the limit as x approaches a with, there's not any superscripts there. This means that this is what we call a two-sided limit. You're approaching both the left and right sides of this x value simultaneously. Okay? So putting that all together, what we're saying is if we approach a from the left and we get L, if we approach a from the right and we get L, then certainly if we approach a from both sides simultaneously, then we're also going to get that same number L. Okay? And the key here is that L has to be a real number. L cannot be infinity for it to be a limit. Okay? All right, so those are the three different types of limits we're going to be looking at. We have the left-hand limit, a right-hand limit, and then a two-sided limit. How do you know which limit you're dealing with? It all depends on if you have a superscript and what that superscript is, or if you don't have a superscript. All right, some quick notes here. If the left and right-hand limits are different, okay, so I told you the case when the left and the right-hand limits are the same, then the two-sided limit will exist, and it's going to be L. But if your left-hand limit is different than your right-hand limit, And what that means is that the two-sided limit does not exist. And what we do is we often write DNE to denote do not exist, does not exist. Okay. Limits must be finite. I told you that earlier. They can't be infinite. And also, this is going to come into play, especially when we get to graphs. A two-sided limit can exist even if f of x does not exist at x equals a. What this means is that even if there is a hole in your graph, or if you don't have a function value at f of x at this particular x equals a value, then you can still have a limit, because a limit is the trending behavior. The limit is not affected by what happens at exactly x equals a. So if there's one thing you could take away from this video, is that a limit is the trending behavior. The limit is not affected by what happens at x equals a. All right, let's get into some examples here. All right. So for example here, they want us to find the limit as x approaches a negative 5 from the left of f of x. So I want to be clear here. The negative, that is the superscript there, that is what indicates that we are approaching from the left. Okay? So don't get the superscript, the power, confused with the actual sign of your value. So we're approaching an x value of negative 5, but we're approaching it from the left. So what that means is that we have a number line. We got negative 5, but we're looking at values that are getting increasingly closer and closer to negative 5. And so, negatives are weird. So that means that to be to the left of negative 5, we're looking at numbers like negative 5.1, negative 5.001, things of that nature. Okay? All right. So what do we have here? So if you notice here, in this table here, we have a column of x values, and then we have a column of output values, f of x values. So we notice as our x's get closer and closer to the x value of negative 5, and that's what we're indicating here, the question becomes, what are your output values? What are these f of x values trending towards? Okay, with the limit, you're never going to get there, but the question is, what are you trending towards? Well, it appears that we're starting to settle down on a pattern. First, we're at 8.6 and a negative 4.2. Negative 3.91, negative 3.99, negative 3.99, negative 3.99. So it appears that the trending behavior for this limit, for this table here, it appears that we're getting closer and closer to an output value of negative 4. So the limit here we estimate to be negative 4. Okay? Once again, the key word is trending behavior. What are your output values? The f of x values trending towards. Okay, how about this one? See if I can make this a little bigger. All right, similar example here. We have a table. This time the table's in a slightly different layout. We have our x values, okay, in the top row, and then we have our f of x values in the bottom row. So let's see here. Find the limit. So part A says find the limit as x approaches a negative 2. Excuse me, that should not be a negative 2. You guys ignore that. That should be a positive 2. Let me actually get rid of that. Yeah, let's do that. All right, so find the limit as x approaches a positive 2 from the left. How do we know we're coming from the left once again? It's that sign right there. Okay, so we're approaching a positive 2 from the left. So what that means is we want to get close to 2. We want to approach 2, but we want to be slightly less than 2. So the way that we're going to approach a positive 2 from the left is that we should be heading in this direction. We have 1.5, 1.9, 1.99. Those are approaching 2, but we're slightly less than 2. So the question becomes, do we see kind of like a trending behavior? And certainly we do. What happens as we come from the left is that we see 4.86, 4.99, 4.9993. So it appears that, yes, we're trending towards an f of x value of 5. So that is our limit there. Why did I not consider what happened at 2.01? That's because 2.01 is not to the left of 2. 2.01 is to the right of 2. And in fact, that's what part B is asking for. Find the limit as x approaches, let's say 2, positive 2, from the right. From the right. So now we're looking at values of 2.5, 2.1, 2.01. These are all values that are approaching 2, but from the right of 2. Okay? The question becomes, what are those values trending towards? Well, these f of x values, we're at negative 10, we're at negative 1200. A negative, I think that's 100,000 there. So notice here, we're not really settling down towards a single value here. We're not, like I said, trending towards a single value. It seems like it's just getting, well, in this case, smaller and smaller. We're heading towards negative infinity. And so what did we say earlier about limits? Limits can't exist, can't be infinite. So if you see a limit that's trending towards negative or positive infinity, what that means automatically is that the limit does not exist. Because in this case, we're trending towards a negative infinity, and a limit cannot be infinite. Okay? So then part C is asking, hey, what's the limit as x approaches 2 from both sides simultaneously? Well, in the theorem that we went over before, it says, hey, if the left and right hand limits are the same, then the two-sided limit is whatever those left hand and right hand limits agree on. Well, here our two limits are not the same. Our left hand limit was 5, our right hand limit does not exist. So what that means is that the limit as we come from both sides simultaneously, this also will not exist because the left hand limit does not agree with the right hand limit. Okay, so that's how you handle limits from tables. Now let's get into limits from graphs. Okay, so let's see, let's make this a little smaller. All right, so for example here, we have the following function. Okay, I'm trying to put this all on one slide here. All right, so the green graph is the graph of f of x. Okay, so it's a graph of f of x. And let's just go in order. So part A, find the limit. Once again, I got these negatives in here. Let me get rid of those. Okay, sorry about that. Okay, so here we go. So let's find the limit as x approaches a positive 2 from the left. A positive 2 from the left. So what I want you guys to do is I want you to focus your attention on this part of the graph that I'm highlighting. Why is that? Because limits only care about what happens when you're close to that x value of 2. But since we are talking about approaching 2 from the left, the question becomes, okay, x value of 2 from the left, do we follow along this branch that I'm highlighting in yellow? Or do we follow along this other branch that I'm highlighting in orange? Well, because we're approaching an x value of 2 from the left, we have to follow the part of the graph that's to the left of an x value of 2. So that means you follow along the yellow branch. And so as you follow along the yellow branch, you ask yourself, okay, what are my f of x values trending towards? And it seems that we're getting closer and closer and closer to that f of x value of 4. Okay, when x is 2, we're getting super close. When x approaches 2 from the left, we're getting super close to a f of x value of 4. So that's why the limit as x approaches 2 from the left is 4. Okay. Part B, what's the limit as x approaches 2 from the right? Well, now this time we are going along that orange graph. And so as we follow along that orange graph, we get close to 2, we see an open dot right there. So if you guys remember from your interval notation and things of that nature, open dot means that that value does not exist there. But what do we say about limits? We said that limits are not affected by if you have a function value there or not. So the question becomes, what are you trending towards? Well, this is getting closer and closer to a f of x value of 3. Just take note of our scale here. So the limit as x approaches 2 from the right, that equals 3. All right. So what's the limit as x approaches 2 from both sides, the two-sided limit? Well, we came from the left, we got 4. We came from the right, we got 3. So since those two values do not agree, they're not the same, therefore the limit from both sides does not exist. because the limit has to be the same from both the left and the right. Okay? And just for, I guess, for completeness here, a little additional question here. What if the question asks us, hey, what's f of 2? Now, this is different than a limit. This is asking for what's the actual function value when x is equal to 2. And in this case, we do care about where our open dots and closed dots lie. But if you're curious, f of 2 would equal 4 because that's where the closed dot is. All right. And then one more. Let's see. Part D. Find the limit as x approaches a negative 1. So this is a two-sided limit. So what we have to do is we have to analyze this from the left and the right and see if they agree. Well, the limit as x approaches 1 from the left, what do you think that limit's going to be? That limit is going to be 1. Okay? What's the limit as x approaches negative 1 from the right? Let's see, here's do a different color. That limit also appears to be 1. So the limit from the left and the right both appear to be 1. Therefore, the limit from both sides will exist as we approach negative 1, and it has to be that agreed upon value of 1. All right? Okay, one more quick question. Here we go. Let's enlarge this one. All right. So here we have a graph. Look at the blue curve, the blue line, so to speak. They want us to find the limit as x approaches 4 from both sides, right? Two-sided limit. So once again, we have to do the same analysis as before. When we approach from the left, when we get close to an x value of 4, ask yourself, what is that limit? Well, it appears, and that would be correct, that limit is 1 as we approach from the left. Okay? What's the limit as we approach from the right? As we approach from the right, okay, that limit also appears to be 1. So if we come from the left, we get 1. We come from the right, we get 1. That means that will we have a limit from both sides? Absolutely. And what is that limit? It has to be 1. Okay? But what about the open dot? Remember, limits do not care about what happens at x equals 4. All they care about is the trending behavior. So whether you have an open dot or closed dot there at x equals 4, that has no effect on the limit. Alrighty, y'all. Hope that helps you get through this next homework. I'll see you in the next video.